Oh, hello. Hello, everyone. It's been a little bit of a vacation for me here in the PerfBytes world, as the summer is just too hot to be sitting in this studio, and I don't have air conditioning in this room. And most people are on vacation, not doing technology things. So my apologies to everyone out there who are doing technology things, and you're like, "Where's my Friday unwinding cool new stuff that Mark's doing?" So that would, that here we are. But we're back. It's been about 2 weeks, I think, 3 weeks of a little respite vacation. And pulling me out for an August dog day of summer, we have a really, really cool show today with some totally cool new technology that I know nothing about, but was totally interesting from the guys at Speedscale. So Matt LeRay is going to join me in a few minutes. But I will first give a shout out to many thanks to the various sponsors over the years, the last few years especially, of PerfBytes. Right off the bat, Scott Moore and Scott Moore Consulting, looking up at the SMC Journal. They're in the show notes, wherever the show notes are below. And you have to say the like and subscribe and all that, but most of you have done that, so that's fine. But welcome anyone who's new. There is a chat. If there's a chat function, you can chat me. But Scott Moore is doing, you'll see some really funny videos on his YouTube channel. Plus, the Scott Moore has 2 weekly interviews on the SMC Journal that I've been on. And it's really, really fun show to be on and keep in the know of kinds of stuff. So check that out for sure. And then our other standby sponsors, Tricentis, of course, Neoload and Flood.io, we mentioned, thanks to those teams over the many years of their support for the podcast and all the various things we do, including the books that James Pulley. We have PerfBytes Publishing. We have 2 books, Leandra's book and James's book. I'm supposed to be working on a book. Haven't quite got there yet. But, it may be the winter months when I'm in the doldrums of having to, the dark season, maybe I'll write. Who knows? But check out Tricentis. Flood.io is at Flood.io. And, of course, Neoload is the tool for load testing. A great combination of those two to cover the entire life cycle in your enterprise of doing that. And, of course, if you've been on Scott Moore's channel on the Perf Tour, there's a bunch of stuff. Tricentis also sponsors the Perf Tour, which is cool. And then secondarily, our friends at Catchpoint APM have done the web page test. So Tim and folks have been over on an interview with Scott. So go over to the SMC Journal and check out the stuff that they're talking about, the web page test stuff from Catchpoint APM. Again, a full-blown stuff. Thank you to all those sponsors, including the one that slipped my mind, which is Ryan Falk and Falk Consulting. You'll see, again, the link there. Ryan has a bunch of expertise in all these new tools. And I'm really hoping that Ryan's whole team tunes into what you're about to see from Speedscale, because that would be very cool. Another sponsor in the background. Oh, they just keep happening, saying thank yous. If you haven't watched the interview with Roger from Abstracta on the Java DSL for JMeter, it's a really cool video. One of the more popular videos that we've done. It might have been in the last couple of weeks that I've done. So over on Joe Colantonio's channel, I think he's been over there. But if you're a Java shop, even if you're not a Java shop, but if you're a Java shop, it is a really cool way to not torture yourself to death with the JMeter, JMX sort of XML-ish hell that they put you through. You can actually write and do all of your programming and everything directly in Java, which is cool. All right. So I'm going to bring in Matthew LeRay, who is the CTO of Speedscale. And Speedscale, a company that I have followed on and off here and there, but I've never used the Speedscale products and such. He can give us a little background. And so I will, let me click the button here. I'll bring Matt in. Matt, how are you? Welcome to PerfBytes.
I'm good. How are you doing, Mark?
I am good. Where are you located, actually, Matt?
I'm actually in Atlanta. I spent a long time in the San Francisco Bay Area, and I moved back right before COVID. So I tell everybody that I knew it was all going to happen, but that's not true. So I was moving back anyway. So
you have a cousin who may or may not work for the government, spend some time at Fort Meade and Baltimore, and then made a call to your mother that called the thing and said, hey, if Matt knows anything, he should move back to Atlanta because that's a safe zone. And of course, the scene where everything is set, isn't that where everything is set for The Walking Dead? Was around Atlanta?
Actually, it's one of the big, a bunch of shows are here. Ozark, we see them around all the time.
Yeah.
I believe they shoot the Marvel movies here, and as well as The Walking Dead. So
Okay,
yeah,
there you go.
or
So
sometimes
it
The
could,
Walking Dead makes sense, but
yeah, the pandemic and The Walking Dead makes good. Well, I'm glad you still have a heartbeat, because you're using the oxygen to your brain in the CTO position at Speedscale to invent this really cool traffic replay for Kubernetes that we're going to talk about. But first, tune me in and maybe tune the listeners in. Give us a little background in terms of Speedscale and your history, and how you get into it and what you guys are doing. Just a little background would be great.
yeah. So me and my co-founders all come from the performance space. So
Great.
performance is, in my case, is observability. So I spent a decade and a half in the observability space doing all kinds of
Yeah.
stuff. Working on tracing and metrics and all the other stuff. And then another one of my co-founders also was in the observability space. He worked at New Relic for a long time, and
Cool.
then worked at another company called ITKO, which fits in the story a little bit. So I'm kind of, it's kind of like when you're a doctor, right? You're watching all these people come into your office, and they're all sick. And you say, okay, I'm going to patch you up. And a lot of observability is kind of like that, even though we don't like to admit it. It's like a lot of I'm going to patch up this sort of busted thing and put it back together, figure out what's going on. But then you sit there and you go, well, what if I could prevent disease? What if I could keep this, keep these applications from getting sick in the first place? And so we started thinking about, what has happened in the last 5 years or so to make it possible to solve the software validation problem in a different way. So if most of us nowadays, a lot of times I start talks and stuff by saying, my name is Matt LeRay and I hate writing tests. I hate it because I do. My name is Matt LeRay and I do hate writing tests. So, so it's like, okay, well, everything else in the cloud world has gone to automation, right? Everything's all about automation. Well, why isn't software quality about automation? Why aren't we planning that? So we went back and forth for months, right? For a few months, thought about it, and said, you know what? We need to create a production simulation engine. So basically, test and prod is great, and for certain things it's awesome, but in other things it's sort of living dangerously.
It is. Yeah.
Yeah, you turn your customers into crash test dummies, which I don't think they appreciate. Many of them. So it works for some folks, not for others, but the vast majority of folks, they need something in the CI system that will validate the software. Well, what does validation mean? Well, it means, did API contracts change? Did we change the performance of the app? Although we never like to admit that. Did we change the performance? Did we change the requirements? Is it have different dependencies now in the environment that are messing with it? Like, it used to talk to this database. Now it has this third-party API. And so we went around and we came up with this idea of traffic replay. And so actually, I can show it on my screen here for a second. I have a little diagram I use here.
With the magic of Restream, I can actually put it in front of folks. So let's do that.
Excellent. All right.
It makes me think there's a couple other folks I'm going to look up here while you're chatting a little bit. I'm going to look up a couple partners that are maybe we're in like 3 different vectors of the same way to approach the problem. And yours sounds really unique. So here you go. Awesome. We'll be down in the corner. There you go, Matt.
Okay, cool. So, traffic replay, we didn't invent it. Right? We didn't come up with the idea. The earliest I actually heard about it was when Twitter did this tool. They released this tool called Diffie, and what Diffie did was pretty cool. It's kind of the center one. So we already talked about the left. You like to live dangerously, only live once. Let's test everything in production. Okay, cool. So the middle rung here is traffic mirroring, and that's what Diffie did at Twitter, and it's very clever. Hats off to those engineers. But basically what it depended on is tapping into the stream of transactions coming in into production. So it was on this cool idea of, let's go and basically fork the transactions and run some of them through the new thing, some of them through the old thing, and we'll run a controlled experiment, basically with 2 controls. And so that was the idea of Diffie. Now, what's cool about Diffie is what I just said, is you can go just check new stuff and get the real user transactions, and you don't have to check it against Swagger or open API specs, or or write test cases or get manual testers. Like, pretty cool idea. But the problem with it is there's actually 2 problems. One is you can only really test with the user load or the requests currently coming through the system. So If you want to run a test at 2 o'clock in the morning, you're kind of stuck with whatever's going on at 2 o'clock in the morning. And if you're Twitter, that's not a problem because Twitter is running worldwide and they have enormous volumes of traffic. That's fine. If you're a bank, something different. Most people aren't awake at 2 o'clock in the morning checking on their statements. So that's kind of like, that's like one deficiency. The second issue is that because of network bandwidth, it is very difficult to move that traffic between environments. So let's say I've got a development environment. I want to test a new version of my code, or I want 10 users to test new versions of their code. This becomes an enormous DevOps problem to keep kind of get that traffic moving around, right? So we came up with this idea of traffic replay from persistent storage. So the idea is we go out, we record from production, grab up all the data, hoover it all up, right? Then we go and create a production simulation environment in Prepod or some other cluster, some other like infrastructure. And we allow you to do all kinds of different tests in there and run simulations inside of that environment without actually impacting production. So when I say a lot of folks, when I talk about this, the easy part to understand is to say, okay, you're going to record the users coming in. Okay. Then if you thought about this and never tried it before, which I have, of course, what you realize is, that's only half the equation. The other half of the equation is I have all these dependent systems. So like, let's say you've got a microservices architecture or a monolith or whatever, but you've got some system. It talks to a database and then it talks to a third-party API. And maybe the third-party API rate limits you. Like most of the big APIs, they won't let you run load tests against them, right? Because you're effectively load testing them when you load test your stuff if you make a lot of calls. And so the mind bender of what we do is we actually record the other side of the application, all the downstream stuff, the databases, APIs, et cetera, and we make that part of the production simulation. So instead of having to do copy databases from production, we simulate those things. We pretend we are those things. And right. So that's kind of the, that's the heart of traffic replay, kind of in a nutshell.
Right. So no mistaking in my mind that some of the DNA from ITKO makes its way in here. A little bit of the recording, the service virtualization layers, and those back-end dependent sources. And so some of that makes it in, but it's actually pulling that technology from being stuck as a back-end stubbing world, pulls it forward. And this is what you and I were talking before about. There's a technology, Ixia had the IX Chariot. And it was like network. It was very layer 2, layer 3. And it was no app layer, no layer 7, no like, hey, you need to correlate this number to the thing and like application bottleneck or whatever. It was still very network and some sources, especially if the storage traffic was there. I mean, if you're in layer 2, layer 3, you could throw storage IO around. But who cares what the storage is doing at that point? It's just packets within the infrastructure. So maybe clarify for me a little bit, as you look at traffic replay, what layers does it play well at? Is it really, hey, I need to get my infrastructure set and the resources set up for pods or for VMs or whatever it is your infrastructure platform is?
Mm-hmm. Yeah. So, every great new technology builds on ideas from a bunch of different places, right? It's like you swizzle these things together. So for us, our deployment looks a lot like a service mesh. So if you've ever used Istio or like Linkerd or any of those things,
the hashy stuff, and the other one I actually we had an Ask Me Anything with a guy named from Meshery, I think it was. They're producing some cool stuff. Yeah, or Nginx. A lot of people roll stuff just natively in Nginx, right?
There's a proxy. To go record from there. So the traffic recording mechanism, we actually work with a lot of different things. Yeah. So we have our own version, which kind of looks like a service mesh. We work with Istio, no problem. A lot of customers do that. We also can use eBPF-based tools. So I don't know if you know what eBPF is, but it's So for those that aren't familiar, there's a new development going on, or it's not really new, but it's a new use of an existing technology in the Linux kernel called extended Berkeley packet filters. And so I first became aware of this with some stuff that Netflix was doing. But essentially what it lets you do is look inside of the kernel and see what's going on with a good degree of security and low overhead.
Cool.
So if you're going to do traffic recording, that's wonderful, right?
That's nice. Would a potential kernel-based trace would be like the old Windows event tracing for Windows, which is similarly like way under there in the system space, but I maybe didn't cover the same. It wasn't specific to packets. It was all sorts of other events, right? It was like a Windows event thing.
It's been a long time since I've worked on the Windows event source, but it's the thing about it. From what I remember, and someone who knows a lot more about Windows is going to correct me, and that's okay.
That's fine. Yeah.
In the Discord. But the event it did get to the level of granularity that's needed. eBPF allows you to actually look inside of like the SSL decoding library.
Oh, great!
And see the HTTP and get the full payloads. Just copy them right out. And so that kind of sort of magic trick. Along with the magic trick of the way Istio does the service meshes and Kubernetes, makes seamless recording experience. So in the past, one of the reasons ITKO got bought and they didn't like hit mainstream the concept is because they couldn't really record traffic. Like it was a very different idea, but they replayed. They understood the idea of creating like mocks, like automatic mocking. So it's kind of an idea. I came from the observability space, which is all about recording what's happening in production. So we kind of took that idea, put those together. And then, like I said, the deployment of the service mesh, you kind of jam them all together, all these different ideas, and you get the ability to pretend you're in production without actually being there.
That's amazing. And it solves a lot of classic problems for performance testers. Where do I run my tests? Do I, not just, we can, I think it was Dan Bartow years ago at SOSTA. Remember SOSTA? They're now Akamai, I think. And Dan was like, this is like tuning the engine on an airplane that's flying at 600 miles an hour at 40,000 feet. That's testing in production. And here's how you do it safely. And I'm like, here's all the safety things. And my compliance officer is still going to say, no, you can't do that. Anyway, but also to a modern, that's the other thing to your point about what I would say is like modern performance testing, modern load test. Well, all the labs are now ephemeral. So if I get a host locked license on a tool of a thing, and I'm like, oh, wait a minute, it has to be in all our partners, Neoload, they all move into the cloud. Even Microsoft got rid of their Visual Studio based load testing and said, hey, we're just going to do that JMeter thing in the cloud thing. So a little copycatish, but good for Azure. They're going after their market. But the other thing is, if you're in Dev and QA, you may not have a full Kubernetes cluster, but you could actually get some stuff worked out in, say, a microcube or something like that. You could get things running, and then, from what I hear you saying, it's pretty easy to say, hey, let's pull in actual traces from production and blow this thing out when it makes sense to do that. So if I'm getting that right, I think you maybe even can do a demo for us, or even show us a little bit of hands-on about how you do this. And before that, maybe we should talk about Kubernetes specific for traffic. Traffic replay does all sorts of different traffic, but the new cool thing that really got me was like you're in Kubernetes, like which could have 40 different pods running around doing whatever it's doing on the worker nodes. But you're recording like in the middle. How do you do that? That's cool.
Yeah. So the technology itself, actually, we kind of support Docker and all kinds of different things. But Kubernetes is where it's so seamless that you don't know it's there, right? So that's when we like to emphasize because it's the cool thing. But actually, let me go and why don't I walk through and answer the question you just asked? But I'll kind of show you a few things as I go.
Yeah, that'd be great.
Oops. All right, here we go.
Ready? Here it comes.
All right.
Ba-bing. There you go.
Okay. We're in the terminal where all of these podcasts need to end up eventually.
Hey, you've joined a live stream just to look at some text.
Yeah, walls of text. Don't worry, there's walls of text coming. But I'll have a little ANSI art in there too, a little ASCII art, so that'll be good. Okay. Good. So the way that the way that Speedscale works is there's two pieces that really matter. There's a recording engine, and then there's the playback engine. So I'm going to show real quick the installation of the recording engine in Kubernetes. I'm using my local Minikube, Although oftentimes I have 6 or 7 of these running because one's broken. So I use microcates for a little while, then K3S and Kind and all those. But for now, it's going to be Minikube.
Yeah.
So what I'll show is installing the heart of the Speedscale engine, which is our operator, right? And our operator is, if you're not familiar with the Kubernetes term of an operator or a controller, it's essentially like a sysadmin in a box. It goes and it says, you go and it yanks levers and pulls and configures your Kubernetes cluster just so. And so we have a Speedscale operator that does the same thing for our pieces. So I'm going to go ahead and now a lot of customers run this. They install our stuff using Helm, which is kind of the popular Kubernetes deployment system. I'm going to use the CLI.
Yeah, totally.
Yeah, I'm going to use our command line tool because it looks cooler. That's really it.
It is. No, it's nice. The Speedscale text logo there is very nice.
Yeah. Well, and it also gives you a better idea of what's happening kind of step by step. Helm just does everything and then you're in. So
yeah. Okay, that's great.
So I'm going to say we're installing with Kubernetes. Here's an explanation for those of you that are going to pause the video at some point. Here's an explanation of what we're going to do. So all the API traffic is going to go inside of your service. And then we're going to record using this. We call it Go Proxy. But we're going to go ahead and record everything going into your service and out of your service. And our Speedscale operator is going to control that. And all the data is going to get sent to Speedscale Cloud, which is a SaaS service right now.
Gotcha.
The next question everyone asks, so I'm going to go ahead and head it off, is we have a data redaction and replacement engine that is on that you can turn on. And so sending it to us is actually a lot safer than recording from your own production. So if you're
so like masking fields, or if you have to get approvals, because you are, like you say, you are using production data. For me, it would be PCI and PII compliance and stuff like that. Yeah.
And in PCI and PII, a lot of times you can't even copy stuff from production to a lower environment, like even within the same organization. So redaction is kind of the like masking things out is the right answer. So we're going to go ahead and install that. I am personally running on Minikube, so I'm going to select that because we configure things subtly different.
Cool.
I'm going to call it Matt-Minikube. I'm not going to enable the DLP engine because my demo app doesn't need it, but it's right there if you need it.
It's nice that it's called data loss prevention because it goes right like, oh, I don't know about this tool. And then here's the terminology that the auditor that knows nothing goes, check. Thank you.
Yeah, I spent a part of my career in a highly sensitive environments, right? Of various kinds, financial services and other things as well. And they love that moment where they go, aha, gotcha. You're going to go send data. And you're like, no, I'm not. So anyway, so our Speedscale CLI, while that's going on, what it's doing right now is it's configuring all the necessary bits and pieces. We custom generate certs because we actually will intercept TLS traffic. So obviously you have to give us the certs to do so. If we had invented a way to open up TLS traffic without needing the keys, I would be selling a different kind of company.
You would be working in the Fed sector and not be able to be on a YouTube channel talking about this. Yeah.
Yes, I suspect you would not know my name if I had invented such a thing. I would be somewhere deep in a lab
That's right.
working on quantum computing or something.
Awesome.
So we're going to let that run. Okay. So I'm going to go and switch over while that's doing it because Kubernetes at times can take a little while to get things done. I'm going to go and I'm going to switch over to what happens right after that because I have previously recorded here.
That's
We're not recorded. This is actually another cluster I'm running.
I'm on.
So 1 second here, and I will be over there. All right. So are you able to see my screen?
Yeah. There you go.
Okay. So you remember the first thing you need to do if you're going to do traffic replay is you need to record the traffic. So once my CLI there is done, we will start recording a service. In this case, I've selected the notification service, and it has been wrapped by that proxy I talked about.
Gotcha.
Now, automatically, no work on your part, right? All you do with CLI, this UI here starts to get populated. And if you're familiar with observability, it looks like a lot like a monitoring tool, but it's not quite like a monitoring tool because it has some superpowers that a monitoring tool doesn't have.
Right.
So this is all pretty standard. Here's the counts of transactions coming in. Here's what's going out. We draw a little service map, right? We're calling my little demo app here called Zapier and Slack and Twilio and Google Cloud and stuff like that. All this is auto detected. So if you're trying to understand like a service catalog of what's calling what, that's all automatically filled in. And then we start to do some slightly more clever things. At least I think they're clever. Let's go and have a look at some of these. So every call that goes in and out, we record and we pull out relevant information.
Gotcha.
You see, we auto detect the technology that's being used, like Envoy, HTML, Istio, et cetera, et cetera. We record every bit of the request. So here's like the headers as an example. Here's
like
the body.
You would with a traditional, like a Fiddler or traditional load testing tool that's doing that kind of recording. Got it.
Well, I don't know if those things actually record at the network level, but they record at the browser level, I think. But
no, there's before a browser existed, we hooked all the stuff. So like Fiddler does a proxy recording. You can do some stuff in the Chrome Dev Tools now and stuff that still hooks into the like a Neko network adapter. But like JMeter does a proxy-based recording the same way Fiddler does, Postman, stuff like that. But at least people would be familiar with seeing it in the semantic of, I have a request, I have a response, I have a header, I have a body, I have raw content. It's at least the visual semantic is very similar to somebody that's a load tester. Yeah.
So all the things you just talked about, I think you're dead on as far as the concept. The implementation is very different in the sense of this is a distributed version of all of those things going across multiple clusters and pods. Like you're saying, it's the whole kit and caboodle. And we didn't set up a proxy, if that makes sense, to go feed data through. So anyway, but it's very much the same kind of idea. So you get all this data, and you're very familiar with it. And if your listeners are as well, you get we get the response and all the usual stuff you'd expect, right? Okay, so that's what the traffic looks like, and we recorded a huge amount of it. Now, the next thing that we do as part of this is we save the traffic and then replay it, potentially in a different environment. So I'm going to go ahead and select just whatever the last 15 minutes of traffic is. Let's say 5 minutes. Okay, I've got the last 5 minutes of traffic. I go and I say, save traffic. Now, this brings us into a wizard that will control your Kubernetes. It'll control your Kubernetes cluster, and it'll run a replay without your intervention. Okay? So I'll show you what I mean by that. Yeah.
Yep.
So because we have our operator running in your Kubernetes cluster and in different clusters, maybe like this is production where we're recording and it's pre-production where we want to play it back. We're going to go and we're going to take the traffic, Speedscale will take care of it, and we're going to go and rewire the networking inside of your pre-prod cluster. We're going to fake it out to think it's in production, but we're going to simulate the endpoints that are missing. So that's the next part of this wizard. So we go through, we just kind of say all inbound traffic on 8080. Again, this is a demo app, so it's fairly straightforward. Some of my customers' applications have 100 of these, but anyway. Here's all the downstream.
So if you're in production, you have multiple different things coming in and out, and you have to kind of select what you want to include in the simulation. Got it.
You got it. So let's say, like, for instance, let's say you're invested in test data management. And so that means, like, you're going to keep certain production systems, you're going to keep a replica of them in pre-production in a sanitized way. Or let's say, like, you're doing machine learning, as an example, and you have something that will you have your models stored, right? And you really want those models. You don't want to record what's in production for the models. You want like the latest and greatest out of your model team or whatever, right?
Okay.
Whatever it is. If you've got something like that, you can say, hey, Speedscale, don't simulate that downstream system. Just take it off the list. And then once you take it off the list, we'll let it pass through to the original system if you want to.
Yep.
So we go through, we hit next. Then we're going to select the pre-production cluster that we want it to run in. So one thing I'm going to point out here is that, do you love Kubernetes, Mark? Do you love working in Kubernetes? Do you love dealing with kubectl and command lines and going in and trying to understand Kubernetes networking? Is that something you?
Is that a rhetorical question, Matt?
Yeah. Or my favorite Twitter
question. I think it is. The closer you are to infrastructure, the more people love it. The less you're in infrastructure, you don't love it. And you look at a lot of demos. I'm thinking about, like, let's say I'm a load tester, a performance person working on a dev team, or I'm a developer in a dev team. I may not even have the access to get to that level of the infrastructure. Exactly. I do stuff through Helm. They give me permissions to run stuff, but I never get under the covers. So yeah, to that point, there's a difference. Yeah.
Yeah, you understand perfectly. So there's a great quote that I love to repeat off of Twitter. I can't remember who said it, and I wish I could give them credit, but they said, one of my coworkers asked me to explain Kubernetes to them, and now neither of us understand it.
That's good.
I love that. That's been my experience as well. So one of our missions at Speedscale is to make, basically give everybody the superpower of software validation or production simulation without having to understand all the ins and outs of Kubernetes.
Yep.
So what our operator does is it also allows you to run the replay without having to touch Kubernetes. And that's a huge value for folks because if you've got, most, like you said it, right, is that most engineers don't have access to their Kubernetes clusters. It's a different team. Yeah. So we go through and say, okay, we're going to run against here. We're going to select a namespace, which everybody knows what that is. Yep. And we're going to go ahead and, as you said, Nginx, we're going to go ahead and run it. And so now I've selected the target workload. We go through. One of the things that Speedscale does out of the box, so those of you who are very astute and have ever tried traffic replay before, you know that it basically doesn't work out of the box. And the reason is you have to mutate the data. You have to change it. And the core things are like re-signing JWTs. Like authentication is going to be out of date, or it's not going to be matching between production and pre-prod, et cetera. There's hundreds of these things. So we have a replay config where you go and say, or transform config where you go and say, okay, this is how I like to transform the data. The other part of the replay config is how do you want it to be like a load test, like a stress test? Do you want it to be a chaos test? One of the things we can do is say, since we're pretending to be all those downstream systems, we can say, hey, let's find out what happens with your application when we start giving it a 500 error every 100th transaction. See what happens, right? Does it recover? Let's slow everything down and let's test out your retry logic. Let's find out if you have a connection leak somewhere, all that stuff, right? That's all built in. So you just select what kind of test you want to run. Yeah. And then you go and you run it. All right.
Awesome.
Once that's done.
One quick question while you're in there. I'm imagining that all of this could be driven from a repo. So you have your defined configs and stuff, and you could get into a repeated continuous kind of thing if you wanted to. Is that true?
So a lot of our customers are into GitOps. And if you've heard the term, GitOps. And for those who don't know, GitOps means you drive everything through your Git repository. So you're not you're not touching anything in the cluster. And we love that. That's great. Please do that with us, right? So for GitOps, what do you call it? So anyway, for GitOps, we are not. We're going to be. You can put it in your repo if you want to, and cause the traffic replays to happen that way. We have mechanisms. They're called CRs. It's a Kubernetes term. But it basically means make me one of these things, and one of these things can be a traffic replay. So make me a traffic replay in Kubernetes.
Yeah, very cool.
Yeah. So so what you get when you run through all this stuff. I'm just going to pick one that we've already done. It works all the same. Let's go and do notification blast. Okay. So what you end up with is you get dumped to this screen here, where you are. We have basically done a performance test against the notification service. So notification service, notify blast, and our standard config we ran. So what does a stress or a load test or stress test mean in this context? Well, maybe the production traffic wasn't that heavy. So you ramped it up, and we can say, let's do 100 times that traffic. And so like in a traditional load testing tool, this would be like V users. But it's not really V users. It's something that's the entire traffic load, right, going against it. Yeah. Then we go and say, okay, we're going to run it for 30 seconds, right? And then you can see the latency of the application as it moves through, and all your normal metrics, right? Throughput, memory, CPU, etc. You can see all of your latencies by endpoint, right? Yeah. And then because we're engineers, we want the detail, right? So what we'll go through and show is the result of every single call, and then we will automatically create what we call assertions, which is very similar to the testing idea of assertions, except that no human coded any of this. So everything I've done, if you start a free trial at speedscale.com/free-trial, if you starting within 5 minutes, you can be here, right? You didn't code assertions, you didn't create test scripts, you didn't do any of that stuff, right? So we go through and we say, okay, do the JSONs match in our request and response? So we made a request to web. Is what we got back, does that match? Okay, cool. It does in this case, right? Yeah. Does do the headers match? Okay, we did a diff for you to say whether the headers match. Here's what we expected. Here's what the actual was, et cetera, et cetera, et cetera. And so we do this over the course of thousands and thousands of transactions. And so we do, we let you know basically if there's been any contract violations. Like if somebody changes an API contract, it'll show up in the JSON diff, right? Stuff like that. So that's the beginning of what Speedscale does.
Yeah. That is wild. So a couple questions come to mind for old school load testers who have to do that manually, figuring out correlation of dynamic data.
Yeah.
It's changed a lot as I watch even in NeoLoad K6 and the load testing space, that you're on the edge of that. You're sort of, because you have the comprehensive recording and not just client into the back, just when you have just one part of recording, you have to correlate. Like there's no way to know where did that data come from here? Where did that number come? Was a request ID and a correlation ID and a state ID? And if you don't know where it came from, you don't know, I have to correlate it because I don't have access to figure that out. Is it true? Or maybe you can explain a little bit. How does it really leverage the comprehensive holistic recording to do a lot of that automatic repair or automatic dynamic correlation?
So when you say correlation, do you mean correlation in the sense of like open telemetry, meaning like following an individual transaction trace through the end? Or do you mean like
an application state, like you logged in, you got a session ID, and then the next time you log in, you get a different session ID. If I replay the static information, that session ID is invalid. So automatically saying that's a session ID, that's always going to be dynamic. We're always going to automatically put a correlation in there. Or in the old world of record and replay, I recorded static, and then if I went to replay it again, it would fail. And then I just keep, it's a very old way of recording and having to fix all the dynamic response, then request, then response, then request, then that kind of thing.
No, we don't have to do that. Yeah.
Yeah. And you don't have to do that. And that is a little bit of magic for guys of my tenure who are like, I built an entire career of spending a week correlating dynamic data in a 800,000 line code script or something, right? I mean, it's like, let's just automate that and solve the problem.
I'm sorry for that you used to have to do that. Yeah.
I learned a lot about packets, I tell you, it did.
Well, there's a, this kind of brings a broader topic, because there's a lot of cool open source stuff out there for load generation. And we actually work with a lot of it. Like, if you want to auto generate K6 scripts, that's cool. Use a K6. If you love K6, do that. Yeah. Right. Yeah. We're kind of we're doing the entire orchestration we're doing the orchestration of the entire simulation environment. So if you want to pick pieces out, that's fine. There's not but yeah, we don't believe in this manual correlation, this manually writing of testing. Look, of course you're going to have manual testing for some things. Let's be serious. Of course there's going to be some of that, but we want everything to be as automated as possible. And that's kind of the design focus of the product, is just make it as automatic. And and kind of fit the Kubernetes ethos with all this stuff.
Yeah. And make it easy from a Kubernetes perspective. Like even half the demos and things that I tune into now and set up at my own company, it's like, if you want to do it the hard way, you have to go over here and read this document. But the easy way is Helm, done. I'm like, yeah, great. Thank you. I just want to get this thing to run. The other, I want to make a comment also, because this would be already set up potentially pervasive within your production environment, and you may not even have a pre-prod environment, but you could have spent Terraform one and away you go. Do you see people implementing this on a regular, continuous basis as sort of release validation? I was thinking about sort of quality gates that happen for functional, like SonarQube does it for security. I mean, you could bring this in as part of a continuous CD pipeline to do release validation before you pushed it out to the real Kubernetes in the real world. Do you see that? And what's the experience folks are having?
Yeah, I'll expand what you said a little bit. There's really three things that people use it for right out of the box, which surprised me a little bit, actually. Sometimes you create a monster and you don't know what people are going to use it for, but fortunately they use it for good and not evil. So the first thing people do is they turn us on in production, and then they can see all the traffic and what's happening. And that's sort of like, oh my gosh, can't believe it, right? They can see now, it's not a replacement for a monitoring system. We're not in the observability space. You still need your metrics, logs, and tracing engine, right? Those are still critical. But if you need to really get in and say exactly what call caused all this to happen, turn on Speedscale and off we go. So that's number one we see. Number two is people use it for new development, actually. And the way they use it for new development is they will go and they will record all the third-party systems that they depend on and then bring that back to the developer desktop. So like whether in Docker or Minikube, they'll have basically all their Google APIs or their AWS, like kind of like AWS local stack, which is a great project, by the way. But AWS local stack, you have to load in your data, right? With Speedscale, you just sort of like, you can just go grab it and the data's sitting there because you got the calls. Then you can develop against it, right? So you can like run a debugger. I do that all the time because I need the debugger. I know other people are more advanced, but I need the debugger. So so we'll do that. And then the third thing is what you said there, where people get to, right? This is kind of the last step in the journey, is they put it into the CI system. Now, the CI systems, there's a lot of them, a lot of Jenkins, a lot of GitLab, GitHub, everybody. And so the experience there, what people most commonly do is put Speedscale as a validation step for performance. For performance, they do it when they're about to merge a PR. So So it's almost like making you'll see a lot of really cool tools out there right now make preview environments, right? Like so it's almost like that same kind of idea. They'll make a preview environment and they'll run all the performance and they'll say, in addition to the code review from your peers, there's going to be a performance review, right? A load performance review, a stress test review. There's going to be part of the PR, and that's where Speedscale fits into that. And then they do a more lightweight version of that where they do API contract regressions pretty much with every commit or every merge. So just, did you mess something up? Because as the bigger the app gets, the more that API contract drift starts to matter. So if you're not familiar, for those of you that have not been around for the time we have, one way that your coworkers can show you that they hate you is by changing the API that you rely on, and they don't tell you about it.
They don't tell anyone about it. It's just like, oh, you didn't get the memo, and you're like, can you show me the memo? Oh, I guess I didn't send a memo.
They're like, I sent that one Slack message. Didn't you see it? And you're like, this is sort of a big deal, you know?
We don't. So we have a free Slack for this team, and the messages are just disappeared. So it's like, just send it on TikTok and it'll disappear.
Exactly. So so what we'll do is we'll say, and sometimes people, I mean, jokes aside, people do it without realizing it. You know, you get a new developer, they don't even know. Another use case people use for us is to say, hey, do people even use this API? Like, for what? Do they use this parameter? This part of the API? Do they do that stuff? And so it's like you can go and run load, so basically regression tests to say, don't change that thing because people actually use it, right? Based on the recording. Anyway, that's a long one.
No, it is great. And again, for somebody that has never done like live trace, I remember doing in Datadog, they had a wonderful live trace. This would be very similar. You could see every single request. New Relic has some of this, Dynatrace has some of this stuff, but I mean, the low-level people that living in the logs world have been seeing a lot of this. But even logging is just one part. It can obfuscate the actual flow of stuff and just say, well, here's some information about what happened. Here's a warning about what happened. And it's sort of a subset of information, may not have a payload, may not even have the stack trace that you want in it or something. So the two other questions I wanted to put to you, which I think would be challenges potentially from our performance load world. One is, obviously you could get stuff, like you say, for the second instance, people are getting in and doing new development, new greenfield kind of stuff. Again, testing at small scale and then testing in production, two totally different animals. The Kubernetes world makes it seem like whatever load you need will be able to auto scale. So one question I had for you is, it helps you validate your auto scaling configurations in your Kubernetes clusters, Yes. And costing and things like that. How much are we really going to run this in? I tested it here, but we had some limitations on a particular component. You mentioned like third parties doing rate limiting. Like, we made some assumptions about those things, and now you could bring those in through virtualizing them. That makes it really easy to test for those conditions.
So you hit on a bunch of really interesting things. So one of our users right now, they use our system to tune their auto scaling engine. So again, I didn't think of that. You did apparently, but they also thought of it. So they use it to tune their Kubernetes autoscalers, and because I mean, Kubernetes is so much better than those of us who are used in the virtual machine or even bare metal.
Yep.
For those who know what bare metal is, it's not the name of a band. It's actually something that predated virtual machines. It sounds like a band name, I know, but it's not.
It does. Yeah. Yeah.
But Kubernetes makes everything so much better. But it's still bottlenecks, right? You still need to put some human thought into how many nodes you're going to run, what's the network configuration going to be, et cetera. So one of them is Kubernetes autoscaling is very popular for this. Another, to your point, I think the more sophisticated your system or the more complex your system gets, the more valuable that something like Speedscale is, like traffic replay.
Yeah.
But for new development, one of the more popular things to use it for, like I said, is to try to bring those third-party systems onto your local desktop.
Yeah.
Without having to actually talk to them. Speedscale pretends to be those things. So.
Yeah, exactly. So, and then of course, if you don't have access to fire up hundreds of nodes, I never recommend, turn on load testing with just keep scaling, and then turn on, and then next thing you know, you get a lovely cloud bill for a couple.
Your
grand.
AWS rep loves you.
That's good for them. I have stock. That's good. I'm good with that. No, you should know. I'm just kidding.
AWS has been very good to us. I love AWS. I love GCP too, right? They've been very good to us. But they also, sometimes I do dread opening the emails to find out what the bill is.
Exactly.
Actually, one of our big case studies actually was somebody taking they were essentially eliminating integration test environments and bringing down the cost of their cloud bill. Basically, bringing down their cloud bill because the Speedscale system is like tiny. It runs in Minikube, right? It's tiny, and we can simulate zillions of transactions. And integration tests are big, and they're very expensive. And I read something somewhere. I don't ever believe statistics, but they said 44% of cloud spend went to pre-prod environments. And so this is kind of a way to say let's get rid of a bunch of that stuff. And
I am a fan, and I've been in situations where a pre-prod or a load test environment had to be large at scale, build data, and you went through a phase of, all right, we've kind of the phase 0, fix all these queries that are bad. Well, now that's pretty healthy. Do I need to test that every day? No, it's kind of running every day in prod, and now we can keep it going, and nothing horrible really will come out. We hope. But you kind of go through these generations of we're fixed all those problems, then we move on to another generation of problems. Then though you can only do so much proactively in that kind of a clean environment. At some point, you're like, I'm just doing performance regression. And it brings up the third case you talked about. Really good. I'm just repeating this and doing a lightweight check to make sure, hey, that thing you changed, it didn't tell anyone, didn't accidentally screw something up for another service, or for unwittingly sending 10 times the traffic to try to achieve the same throughput or something, or the same output. So there's some interesting things to think of in that. I did want to cover before we roll into the end here. I put up the thing here below, which is the free trial. Speedscale is not a sponsor of PerfBytes, which is totally fine. I think we're actually going to go to just like a Patreon model in the new year, just because we have people that are like, yeah, I can buy a coffee, and the buy me a coffee thing.
Yeah.
But I did want to just encourage, because you had reached out to me. And just said, hey, would you ever want to get, be on? I'm like, that'd be great. Let's talk about it. And I'm glad we got to show it a little bit. People should check out the free trial. What else should people know as they jump in feet first into the deep end of the trial?
Join our Slack community, because we're a startup, and we want to hear what we can do better. Like, I don't mean what we can do better in the self-deprecating way. I mean, what we can do better, like, hey, if you got a problem, we want to hear about it because we want to solve it for you.
Yeah.
Right. We might go build something overnight even that will solve your problem. And so we as a startup, it supports us to go into our Slack community. It supports us to tell us what's going on in your world, so that we can be more effective and hopefully eventually not be a startup. That'd be great one day. So
That's one part. The other part would be you can get started as small as just running this on your local machine. If there are some folks in a company or a corporate setting where you might need to requisition some machines, they could still get started with just a single or maybe even a couple of machines and get the free trial up and running. Are there other ways they could do it? Cloud, maybe free instances in the cloud or something?
Well, so we offer as you said, we offer the free trial. We actually have a blog post where you can go and run it on your laptop and test everything out and try it out. So you don't need to even invest in cloud resources. On top of that, so on top of that, one of the things that if you don't want to go through the process of recording and it's kind of like too heavy, we actually are getting ready to release a Postman importer. So if you have a giant Postman collection, you'll be able to hoover up that Postman collection. We'll automatically take it in, turn it into a load test, orchestrate the environment, and let you kind of go from Postman to stress test very quickly, because I think that is not so easy sometimes for folks.
It's not. I end up, hey, we need to import a script, go into K6. I need to go into LoadRunner or Neoload and some of these other products. And they're like, well, I have a Postman script. And I'm like, just send me the Postman script. I'll figure it out. And I replay in Postman, record in the target tool, and then hobble it together. So it's nice. The importers are good. There's a couple different ones. Oddly, importing stuff or like exporting stuff out of JMeter is just absolutely insane, just because of that darn JMX XML fiasco.
So I used to work at a company that owned BlazeMeter, which is the commercial version of JMeter. So I'll pass along your feedback.
No, that's fine. No, Flat.io, our friends Tim and Abstracta. Oddly had done a bunch of the stuff for BlazeMeter behind the scenes. Abstracta was the JMeter. So Roger was one of the main contributors to do a bunch of the BlazeMeter plugins. So it's a small world.
JMeter is a great tool.
But like I was saying, performance wise, it is a small world. I'm glad my world just got a little bit bigger by meeting you. So thank you very much for reaching out to me. Sincerely, I want to keep an eye on what you guys are doing. I think I'll give a free trial myself and see if we can get that going in our world. You can follow Speedscale. It's at Speedscale on Twitter, right?
I think it's actually Speedscale AI. We were having an identity crisis early in the company, and we didn't know what to call ourselves. But I think it's fine. Speedscale AI.
That's good. You can hire Macaulay Culkin as your whatever the robot, the iRobot little. I forget the character's name of the robot. Who was Tony?
I don't remember.
I can't remember whatever the robot name was of the thing. And Will Smith. They found a way at the end to work it out, but people died. I'm just kidding.
You've got to be nice to robots, because they may be your overlords one day. So
that's right. And Amazon has now acquired or iRobot, the actual Roomba thing. So next thing you know, Jeff Bezos is mapping your house. So that's nice. Exactly. Sincerely, Matt, thank you very much for joining us. And this will be continued on in YouTube. So, we can share out the link and that kind of stuff. But this was really cool to learn about. And thanks again.
Thank you. Thanks, everybody.
Okay.
Bye-bye.
Ciao. I have to do the graphics thing here or figure out something like whatever. All right. We'll catch you guys next time. Thanks.